Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. We are doing preparations of aldehydes and ketones. In our previous videos, we did the methods of preparation of both aldehydes and ketones. So, in the second part, we will do the methods of preparation of aldehydes only and methods of preparation of ketones only. It is from acid chlorides. So when acid chlorides are reduced with hydrogen in the presence of palladium as catalyst supported over barium sulfate and sulfur or quinoline acting as a catalyst poison, then in that case the acid chlorides, the H of hydrogen will react with the Cl of acid chloride to form HCl, and H will be attached in its place forming aldehyde and HCl. Next, this method is known as Rosenmann's reduction. Similarly, acetyl chloride with hydrogen, we get CH3, CHO and HCl, and benzoyl chloride with hydrogen, we get benzaldehyde and HCl. The limitation is formaldehyde cannot be prepared by this method because the acid chloride from which it has to be formed is unstable. Alternatively, we can also reduce acid halide with tertiary butoxide aluminium hydride at a temperature of minus 78 degrees centigrade to form a compound which is then hydrolyzed to form aldehyde. Second method is from reduction of alkyl cyanides or nitriles and esters. So when cyanides are reduced with a mixture of stannous chloride and hydrochloric acid in presence of dry ether, nascent hydrogen is produced which will reduce this nitrile into aldimine, which on further hydrolysis will form acetaldehyde. So this bond breaks, two hydrogens are added, one here CH3CH, another here double bond NH. On hydrolysis, bond breaks from here, oxygen added here, two hydrogens added here to form ammonia and acetaldehyde. The reaction is known as Stephan reduction reaction. Similarly, if we will reduce benzonitrile with stannous chloride and hydrochloric acid in presence of dry ether, we get benzaldemine, and on subsequent hydrolysis we get benzaldehyde. Ketones cannot be prepared by this method. Alternatively, nitriles and esters can also be reduced with mild reducing agents such as diisobutyl aluminium hydroxide, which is also known as DIBAL, diisobutyl aluminium hydride. Two imines which on hydrolysis give aldehydes. The temperature of minus 78 degrees centigrade is obtained by dry ice acetone bath. This low temperature decreases the reactivity of the reducing agent and therefore prevents the reduction of aldehydes to alcohols. So on reacting nitriles with diisobutyl aluminium hydride and then hydrolyzing it, keeping the temperature low, we get aldehyde. Similarly, esters are reduced by DIBAL and on subsequent hydrolysis will form the respective aldehyde. So this is ethyl undecanoate and 11 carbon aldehyde will be formed on its reduction and subsequent hydrolysis from aromatic hydrocarbons by oxidation of methyl benzene. So on oxidizing with an oxidizing agent like alkaline or acidic cheminophore or acidified potassium dichromate, the methyl benzene gets oxidized to aldehyde, but it further gets oxidized to benzoic acid. If we want to limit the oxidation to benzaldehyde stage, we can use different reagents. For example, use of chromic oxide in acetic anhydride. Acetic anhydride gets acetylated over here. Acetyl groups is attached over here in place of two hydrogens to form benzalidine diacetate or geminal diacetate at a temperature of 273 to 283 Kelvin. So this on subsequent hydrolysis, this is isolated and then hydrolyzed with aqueous dilute HCl or sulfuric acid. So oxygen of water is added here and two hydrogens are added to acetyl groups to form acetic acid and benzaldehyde. So alkyl benzene, when reacted with chromyl chloride, two of the hydrogens will be added to the double bonded oxygen over here, and the second oxygen will get attached at this position to form brown chromium complex. This two times this group is added. This on hydrolysis, again oxygen is added here and two hydrogens are added to the two groups to form chromyl dihydroxychloride and benzaldehyde. This reaction is known as Etard reaction. Once again, alkyl benzene is reacted with chromyl chloride in presence of carbon disulfide to form a brown chromium complex C6H5CHOCrCl2OH, which on hydrolysis will form benzaldehyde. In case the side chain contains an alkyl group greater than methyl group, then the end carbon will get oxidized to aldehydic group. So for example, ethyl benzene will get converted to phenyl ethanol. We can also do side chain chlorination of the methyl benzene and then carry out its hydrolysis. So two hydrogens are replaced by 2Cl2 when we react with chlorine in presence of sunlight at 383 Kelvin temperature. Of the chlorine, one chlorine reacts with hydrogen, the other chlorine gets attached in its place. Two such chlorines are attached to form benzyl chloride. Now on hydrolysis, that is reacting with water at 373 Kelvin, the 2Cl gets replaced with OH group. Now 2OH, 2CH at the same carbon atom, it's unstable and a water is removed and benzaldehyde is formed. This is the commercial method for preparation of benzaldehyde from methyl benzene. Next reaction is Gattermann-Koch reaction. So benzene or benzene derivative can be converted into benzaldehyde by reacting with carbon monoxide in presence of hydrochloric acid using anhydrous aluminium chloride or cuprous chloride as catalyst. Benzaldehyde is formed. CH is already present here, CHO group. This CO group also gets incorporated to form CHO. Now just to remember, this reaction is known as Gattermann-Koch reaction. So just to remember the reactants used and the product used, just remember this reaction as Gattermann-Koch aldehyde synthesis reaction, and we will read KOCH, but we will think COCH as Koch. So that means there are two reactants, CO carbon monoxide and CH, C for chlorine and H, Gattermann-Koch reaction. So once again, benzene on reaction with carbon monoxide in presence of hydrochloric acid, anhydrous aluminium chloride or cuprous chloride, benzaldehyde is formed. Then if we use, in place of carbon monoxide, if we use hydrogen cyanide in presence of HCl in presence of anhydrous aluminium chloride, then of the HCN, we have a triple bond between carbon and nitrogen. Nitrogen is more electronegative. The electrons move here, so positive charge comes here, and electrons will move to this positive charge, whereas the hydrogen will move to nitrogen to form C6H5CH double bond NH, and HCl also gets attached. Now this is benzaldemine hydrochloride. On hydrolysis with water, on boiling with water, O is added here and 2H are added here to form NH3, which combine with HCl to form NH4Cl, and CHO C6H5 is benzaldehyde. Hydrocyanic acid. Hydrocyanic acid reacts with Grignard reagent in the presence of dry ether. The electrons of the triple bond move here. One of the pi bond electrons move here to more electronegative nitrogen atom. A positive charge comes here. So negatively charged alkyl group moves here and positively charged MgBr moves to nitrogen. So what we get is CH3CH double bond NMgBr. Now on hydrolysis with water, water will break up and add on this compound. One water molecule breaks in such a way that an oxygen comes here to form aldehyde and two hydrogens to form NH2. Another water molecule will break up. Of it, one H will come here to ultimately form NH3 and the OH comes here to form MgOH-Br. So aldehyde, ammonia and magnesium hydroxybromide are the final products. Another method is Rosenmann reaction. So when phenolic compound is reacted with chloroform in presence of sodium hydroxide, first thing is OH gets converted to phenate ion, sodium phenate, and chloroform, the H of ortho position will get attached to one of the Cl to form HCl. It gets removed. This CHCl2 get attached over here, but the CHCl2 on hydrolysis with NaOH will form CHOH twice, which is unstable, so water is eliminated. So ultimately the benzaldehyde is formed, and we also have oxygen Na position ortho to it. On hydrolysis, on reacting with acid, dilute acid, Na gets substituted with H to form salicylaldehyde. This reaction is called Rosenmann reaction. Methods of preparation of ketones only. We react from acyl chlorides, we react with dialkyl cadmium to form this ketone. Now the dialkyl cadmium is formed by reacting Grignard reagent with cadmium chloride in presence of dry ether. So the two alkyl groups get attached with cadmium, whereas the two Cl go to the two MgX portions to form magnesium halide chloride. Now this dialkyl cadmium reacts with acyl halide to form ketone. Two Cl of two acyl halides will react with cadmium to form cadmium chloride, and this two R get attached to two RCO groups to form two ketones. This reaction cannot be done with Grignard reagent, because when we react with Grignard reagent, of course we get a ketone, but this ketone can further react with another Grignard reagent to ultimately form a tertiary alcohol. Whereas if we react, instead of Grignard reagent, we react with cadmium, dialkyl cadmium, it's a weaker reagent and has no tendency to react with ketone. So once again, we make dialkyl cadmium by reacting Grignard reagent with cadmium chloride, and then we react dialkyl cadmium with acyl halide to get a ketone. And we react benzoyl chloride with dimethyl cadmium, we get acetophenone. From nitriles by Grignard reagent reacts with nitriles. The electrons of the pi bond move to nitrogen, positive charge comes here, so ethyl group migrates here, MgBr goes to the nitrogen. We get this compound, CH3, CH2, C, CH3, CH2, C, CH3, and double bond N and MgBr. And on reacting with acid and water, or on hydrolysis, O comes here and 2H2 here. So we get CH3, CH2, C, CH3, double bond O. And again, another water molecule H over here and OH over here to get NH3 and magnesium hydroxybromide. Similarly, phenyl magnesium bromide, when reacted with propane nitride in presence of dry ether, will form this compound, ethyl phenyl ketone, along with ammonia and magnesium hydroxybromide. From benzene by Friedel-Crafts reaction also we can prepare ketones. So benzene, when reacted with acyl halide in presence of anhydrous aluminum chloride, H gets reacted with Cl to form HCl, and COCH3 gets attached in its place, so we get a ketone. Similarly, when we react with benzoyl chloride, we get a benzoyl group over here and a ketone is formed. This reaction is known as Friedel-Crafts acylation reaction. Next method is from phenyl esters by Fry's arrangement. So when phenyl esters are reacted with anhydrous aluminum chloride in carbon disulfide and heated, the H position of ortho position, the hydrogen of ortho position will come here, COCH3 group gets rearranged to the ortho position. So we get ortho hydroxyacetophenone. Same happens at para position, we also get para hydroxyacetophenone. Similarly, phenyl benzoate reacted with aluminum chloride in presence of carbon disulfide and heated will form ortho and para hydroxy benzophenones. Now, this para compound is more stable at 330 Kelvin. It will be formed in more amounts at this temperature. This will be formed at more amount at this temperature. And the reaction is known as Fry's rearrangement. That is all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.